Good evening, ladies and gentlemen. Thank you very much for giving me floor. Today, I will talk about newest research published in Chemical Engineering Journal about microalgae anaerobic digestion. This work is entitled "The Role of Hydraulic Retention Time in Integration of Microalgae in Activated Sludge Process for Nutrient Recycle from Diluted Dairy Liquid Digest." Work is under leadership of Sydney University Professor Hu Hao, with cooperation with Guangzhou University under leadership of Lei Qin. What is this Mr. Effort? A macroalgae, an activated sludge, hydraulic retention time, that really quickly digested, biomass production, and metagenic analysis are key parts of this analysis. The integration of microalgae and activated sludge processes presents a promising method for recycling nutrients from animal digestives. However, the effects of operation factors such as hydraulic retention time on this process remain unclear. Therefore, this study utilized semi-continuous photobioreactor system with a working volume of 800 milliliters to investigate the impact of three different hydraulic retention times: 4 days, 6 days, and 8 days, on the performance of macroalgae and activated sludge processes for nutrient recycling from diluted dairy liquid digestate. Results indicated that 8 days of hydraulic retention time yielded the highest production. This is how the research how hydraulic retention time, high heating value increase due to changes. Economic growth and population expansion have led to a surge in demand for new products for utilization of manual wastewaters as new energy and chemicals, sustainable development, and digestion is common strategy for managing such waste. However, liquid digestate, the byproduct of anaerobic digestion, can pose a threat to the ecosystem if improperly untreated. Unfortunately, traditional methods of liquid digested treatment, such as ammonia stripping and aerobic biological treatment, are costly and treat the liquid digest as waste and use much of water, and can produce some carbon dioxide, which is major goal to reduce, due because this is factor in increasing greenhouse effects and global warming. Therefore, we need to find the professor and Gawel try to find method in this research to overcome this trouble. Agabacteria symbiotic system has gained popularity as a feasible alternative to improve wastewater treatment performance. In Agabacteria symbiotic system, bacteria aid in chemical oxygen demand biodegradation and release carbon dioxide for algal photosynthesis, while the oxygen produced by macroalgae serves as an electron acceptor from bacteria to oxide organic compounds. The macroalgae and activated sludge system has emerged as a viable alternative for wastewater treatment. In comparison to to algal bacteria symbiotic system, macroalgae and activated sludge systems are easier to construct and distribute, improve bioremediation abilities, therefore a chemical oxygen demand, nitrogen and phosphorus. They also have better sedimentation capabilities and emit lower levels of greenhouse gases. Moreover, microalgae activated sludge process has been extensively researched for wastewater remediation and biomass recovery. Performance of this is influenced by various factors such as illumination and the inoculation ratio of microalgae and activated sludge. Then, microbial algal system proved to be efficient for achieving good remediation efficiency as well as absorption of metals. This case is lived bioreactors, photobioreactors are one of potential design. The experimented was activated sludge was collected from the aerobic tank in wastewater plant in Guangzhou in China. This liquid digested was collected from an aerobic digester at the dairy farm of Guangdong in China, and it was then centrifuged and filtered using Wortmann glass microfiber filters to eliminate the adverse effects of large particles before being stored to 4 degrees refrigerator until further use. Our previous study found that 25% of liquid digestate was operated for organism growth, nutrient recovery, and biofuel production. Therefore, the liquid digestate was diluted and ionized water at a ratio 1 to 3, resulting in a pH of 6.7. Chemical oxygen demand of 360 mg per liter, total nitrogen of 151 milligrams per liter, and total nitrogen of 130, and total phosphorus of 60 milligrams per liter. Considering that the treated liquid digestate could be reused to dilute the raw dilution, wouldn't affect the industrial application. The axonic strain of microalgae, NIES 2027, was cultured in both medium. Both medium were shown per culture in a 5 centimeters diameters, 60 centimeter high are lived by photobioreactor with a working volume of 800 milliliters. The pre-culture was conducted under continuous illumination and room temperature while aerating the mixed air containing 2% of carbon dioxide into the photobioreactor with flow rate of 0.3 volume per minute. Microalgae and activated sludge were co-culture in the same air lift at a concentration 0.4 gram per liter with a mass ratio 1 to 1. The microbial activated sludge was per culture for 3 days, reached the log phase and accumulated biomass. Then aeration was halted and the system was settled down 30 minutes to precipitate microbial algae biomass. Subsequently, 50% of supernatant was replaced with diluted liquid digestate every 2, 3, 4 days, respectively to hydrolyzation time. The drive weight of microbial algae was measured and with 10 milliliters sample was filtered through Wattman glass filters. In the filter was dried at oven 105 degrees for 4 hours. The weight of the dried filter with biomass was determined by subtracting the weight of the filter alone. Microalgae was monitored by measuring the contents of chlorophyll. To extract the pigments, 1 milliliter of sample was centrifuged and resulting pellet was resuspended in dimethyl sulfoxide and placed in a water bath at 55 degrees Celsius following the measure. The absorption of the extract was measured 649 nanometers using a spectrophotometer. The water quality was used by centrifuging the sample at 10,000 waters per minute for 5 minutes through nylon membranes, and then measured chemical oxygen demand, nitrates, and this was by water quality analyzer. The statistics was by statistics triple times repeated. The biomass potential was using by higher heating volume, by freeze-dry material, where they specifically used the Brattleford method, constituted 10 milliliters of diluted water, aliquots of 2 liters were mixed with concentration of sulfuric acid. The sample were quantified and by calibration curve and by spectrometer 490 was measured, as well as chloroform was measured in the in the case when in the temperature of 40 degrees, and this was to other photos. As a result, we have 3 cycles, and we observe that in case of nitrate concentration, the most decrease was for 4 days, the lower decrease was for 8 days. So the 4 days were the lowest, the highest, while 6 days was the medium. So they fell for 4 days and 8 days, similar, but in case of nitrate free, the biggest was for 6 days. This shows that the different was for different nitrite, different denitrification and improved cleaning were different for days. And this is what we have if we want to solve this problem. We need to change the first time to 4 days, a 6 day some part. So we need to separate this to samples according to nitrates. The microbial community show good increase, especially on 6 days. So we have the 4 days was good for nitrates, but biomass will prefer for 6 days of hydraulic retention time. As a result, the most was product bacterium, especially in 4 days. But the highest was in 6 days. So this shows the different occurrences, the research, the effects of different hydraulic retention time, dilated treatment, and 4 days were resulted at highest nitrates, but since there was the biggest growth of bacteria, so the biggest oxygen carbon dioxide capture, so we see such lipid content was in 6 days. So we see that due to our difference, what do we want to obtain? If we want to liquid content, the lipid content was higher by 6. However, lipid for especially for lipid content, not to chemical oxygen demand, not 2 days, not 4 days, but liquid content was the highest after 8 days. So the longer time, more lipids were in our class. However, the 6 was the highest growth, but not so containing so much lipid. So we see this analysis how different factors are changing due to different hydrolyzation time and dilution. So thank you very much for listening